Hey, this is Arnav from Scale Up. Welcome to yet another episode of Refactor where we discuss tech and tech career related topics. Today we will be discussing about different software engineering roles in tech companies and which ones you might be interested in going for. So the reason we're discussing this topic about different software engineering roles is because it's yet another query that keeps coming a lot, and then I get asked about this. I think especially more from people who are early in their careers about which type of software engineering career I should pursue. And there's a lot. People are confused between backend versus front end versus full stack, or what is SRE, what is DevOps? Should I become a data engineer? I've heard that there is more money as a machine learning engineer, and then a bunch of questions around this. And I think this is something that's fair enough to come in your mind when you're starting with your tech career, or also if you've been in one sort of domain for a while and you're looking to switch, then how should you go about it? So we'll discuss all about it. We'll discuss what kinds of roles exist, a little bit about the ladders that exist as well. But I think vertically speaking, how the ladder goes as an engineer, how you get senior and into engineering management and all that itself can make for a separate video as well. Today we will focus more on the types of domains in the technology pipeline that you can work on, right? So I'll mostly be talking about engineering roles that exist in product companies, startups, and MNCs. I'm not going to be going into a lot of roles which exist in mass scale service companies like something called systems engineer, etc. So I'm not going to be discussing that a lot. I'll talk more about the product company roles. So let's get started with something that's the most common lot of role that a lot of companies hire for. The larger companies is called SDE, software development engineer. And if you look at any big company, like the companies which hire tens of thousands of engineers, they always hire for SDE roles. At least at an entry level, they hire for SDE roles. Sometimes they don't even tell you which team you'll be working on, especially when people are getting hired from campus or freshers they're hiring. They're like, it's an SDE1 role, software development engineer level 1, right? This is a very generic way of hiring people. At the end of the day, when you're hired and you would be working on either the backend systems or somewhere on the front end or on mobile teams or a data team, something like that. But what happens is at an entry level, you generally would be working in a team which has more senior engineers, would have a tech lead, would have an engineering manager, product manager. So your work gets cut out. Like you will have to mainly work on one piece of logic. And as a result of that, the way larger companies are, the teams are orchestrated, as a SDE1, even if you're put to work on mobile development or front-end engineering or back-end engineering, your work is less platform dependent, more about logic, business logic processing, like, okay, data coming from here, passing there, or, making an observer, like if this data changes, then make this other data change. So that kind of stuff is very generic in nature, and you could sort of work both in back-end, in front-end, with sort of basic programming knowledge as your skill set, right? So what also happens is in fairly large companies, the companies prefer to hire for people who can be switched between teams easily. So today you're working on a backend role, you could be switched to a front end role more easily, at least till a mid-senior role, like as an SD 1, 2, 3, these kind of roles, unless you reach what is generally companies called a staff engineering role. So generally bigger companies have a differentiation between line engineers and staff engineers. A line engineer is somebody who works on features, fast moving products. Staff engineers are people who work on the platform, who work on larger scale products. So until you are a line engineer or an SD 1, 2, 3 kind of roles, the companies think that you should be versatile enough, you should be a good problem solver who can be put into different kinds of roles. That's what happens in the bigger companies. But also there are fairly big enough companies, like I can give you an example of, say, Twitter, for example. Big company, right? And lots of people use it. But Twitter hires for mobile developers, like an Android developer, iOS developer, or front-end engineer separately from back-end engineers. They do hire that. But say something like an Amazon or a Microsoft or a Google, they don't really do that, right? The reason they also don't do that is because the next role that I'm going to be talking about, which is the most common role, like the biggest chunk of the engineering team forms, is the back-end engineering role, right? So a large number of people who work on big tech companies, they work on cloud-based, server-based systems which have an input-output interface which is going to be an API. That API can be connected to by other clients, which could be a mobile app, could be a web browser, could be another microservice, could be another server which is connecting to your project via an API. You store data in a database and you write some business logic somewhere. Now, this is a typical backend engineering role, and even for companies which looks like, as a consumer, it looks like an app, like Uber is an app or Zomato is an app. And you think that, okay, like most of the people who are working at Uber would be Android or iOS engineers, or most of the people working at Zomato would be Android or iOS engineers. That's not the case, because the app is really a very small component of what you're seeing, right? How are the orders placed, the data of the restaurant stored, the data of the ordering stored, or in case of Uber, the data of which cab is in what location, how to price. All of that stuff happens on the server, on the cloud. So in all of these teams, actually, there are much more larger teams working on backends than on the mobile apps. The mobile apps are fairly complex, have a lot of features, and they need a lot of engineers. I mean, say, for example, at Zomato, there would probably be some 50-60 people working on the mobile engineering team. It's not a trivial project, very large scope of work. That said, there would probably be 150 people working on backend still, maybe 200 people working on backend. Why? Because there are a lot of services out there. There is the, let's say, allocating riders, fixing prices, payment services, updating menus of restaurants, keeping track of, which order is at which place right now, so that those tracking data can be available, collecting locations of restaurants, processing ratings and reviews, bunch of things happening on the server. So there's most tech product companies would have very huge backend teams. Now, this is about consumer companies, but if you look at B2B companies, like let's say a company which makes services that other companies are using, let's say something like a Freshworks, which creates systems where you can do processing sales leads, track your marketing projects, or you have a talent pipeline, like you're hiring people, is an application tracker system, enterprise software. All of this, again, like there's going to be very simple web dashboards that people do interact with, but all of that is data processed in the backend. So there's going to be backend engineers who work on this. Now, as a backend engineer, largely your systems are going to be like, there's a IO interface, like I said, API, storage, data storage, and logic around it. And as the companies grow bigger, more and more of your business logic processes get extracted out as small modules, and that's what we call microservices actually. So different services get created, and this is something that has the maximum number of jobs. Like if you go and look at jobs that exist in languages like like Java or Node.js or Django, Ruby on Rails, these all frameworks, they're all backend frameworks, and there are tons of jobs in this, right? And this is something pretty evergreen. Jobs in this field has been there for a long time, will definitely be there for again another long time. That's one. The next thing is, of course, software has to have an interface, and the most evergreen interface that people have been interacting with always is like the web browser, where you have a web dashboard where you can interact with. Long back, most software used to be desktop apps, like let's say Windows Office or the Adobe Suite and all of these things. But slowly you will see everything is moving to web. For example, these days, instead of Photoshop, a lot of people using something like Canva, which is web based, or instead of Premiere Pro, people using InVideo, which is again web based. I think latest generation of people getting out of college and all, they probably have used more of Google Docs than they have done on Microsoft Office Suite. So a lot of these software happening on the front end, which means all of these interfaces have to be built on the front end, and that's where the next role to talk about is the front-end engineering, which is, I'm talking about web front-end. And web front-end engineering is again a very vast field, because all software, whether it's a consumer software, whether it's a enterprise software, they need to have an interface with which your user will interact with, and that 99% of the cases it's a web software, apart from maybe products like, say, a cab hailing app, which makes sense only inside a mobile phone, which is going to be a mobile app. And Uber does not have a very complex website. Their website is more like a landing page, and everything happens on the app. That's a one-off case, I would say. Mainly you would have websites, right? For example, even our example at Scale Up, the whole learning management system where people are having live classes, doing assignments, everything is on the web, because people do it on their laptops. They don't do it on the mobile, right? And this is also a fairly vast field. I think large number of software engineers work on as front-end engineers. In this field, obviously, there are again some frameworks that people who are working with React or Angular or Vue, they are all front-end engineers working on the web. And this is a field which also involves people working closely with designers, because you're designing UI interfaces. You should yourself have a knack of a good eye for design as well, right? Because there are going to be some gaps which your designer does not cover when they say that, okay, we are going to be building this, the design, some screens. Might be some transitions, some dialog boxes, some buttons, things that you have to add into the project yourself as well without having designs in place. So your own design skills definitely are going to be helpful here. And if you want to work on the interface with which people interact. And there's a whole domain for this in computer science called human computer interaction. Like placing the button, where does it make people interact with it more, what makes it more convenient, which fields are more important, you move them to the top, which actions people do more, keeping those CTAs larger. All of these things play here, and if this is something that you really love doing, then front-end engineering might be your cup of tea there. When we talk about front-end engineering, I should also then move on to the next thing, which is mobile development, right? And mobile development is also another very large field. The reason is that most products which are B2C, which is like consumer products, which a lot of end users are going to be using in their daily lives, they tend to be in a situation where if you have a mobile app, more people end up using a product over the app rather than the website. For example, YouTube. There are more views of YouTube happening over mobile YouTube app rather than the YouTube website. YouTube started off as a website. YouTube did not have a mobile app for many years, right? When mobile apps were not even that popular, YouTube used to exist. YouTube exists since before the iPhone and Android phones have come up into the market. Obviously, when these phones came up, they started viewing YouTube over the youtube.com website. Then people thought that, hey, we will make an app. Now with an app, what happens is it's very much like web development, but there are a lot of additional things. Like if you have an app, then you can send people notifications, right? For example, a Zomato or a Swiggy might send you a lot of notifications during dinner time that you can order this food, or a bank might send you notifications about paying your credit card bill or your electricity, telephone bills, these kind of things. So that's one thing that differentiates, let's say, a mobile app from a web app, because you are more contextual, closer to the user, always there on his phone. You can notify them and trigger them to use it, which a website can't do. A website, people only when they visit a website, then only it's used, right? Your screen form factor also changes. It's vertical, so you usually do things which are long scrolling lists. Like you will see most apps, like a YouTube is a long scrolling list of videos, Twitter is a long scrolling list of tweets, messaging apps are a long scrolling list of messages you have shared with each other. So mobiles have a little different user interface in that sense. You don't have a landscape like dashboard kind of a thing, right? And also you have products which make sense only when the user is on the go, like cab hailing apps, for example, right? Or also you would see that things which people don't really need to open a laptop for, like I run out of grocery, I want to order grocery from something like a Zepto or a Grofers or a Big Basket. They make more sense. Like, do you think that this is something that people would open their laptop and order from a website? They would probably not. They would want to do it from a mobile, and they would want to see that they might want to have a partly created cart, and then they forgot ordering. The app can give them a notification that, hey, you have a partly created app, do you want to finish ordering? And make the payment via UPI, which is also on mobile. So mobile apps are, I would say, rather than websites, even closer to the user. So mobile apps also can have caches. For example, if you look at social media apps, like let's say a Twitter or a Facebook, you would see that even if you don't have internet, you can actually open the apps, and the recent tweets or posts, you can still see them. You can in fact even like them. The like will not get submitted to the server. So when the next time you have internet, the likes you have done will get submitted and all of that. But that's a significant engineering effort to actually present a slice of that social media's content and some of the interaction that you can do offline on your mobile. So it's a a little different field, not exactly like what web front-end engineering is. And also mobile engineering jobs, of course, they are a little different, like I said, from web development. And it's also very context specific. Like Android and iOS are a little different. There are some tools like Flutter and React Native which makes developing apps for both a bit similar. But still, if you're working with video capturing, QR codes, location, camera, these kind of things, you still need Android and iOS specific knowledge. As a result of which, there are quite large companies like, for example, I know Twitter or Spotify or even Target, a company I worked at earlier, which have fairly big engineering teams, and they still don't hire for mobile teams like Android, iOS in the similar way they have for backend. They have a separate hiring process. They're looking at Android and iOS specific skills for that. And this is a field that going ahead is going to get more and more important. For example, there was a time when desktop application engineers were sought after breed of engineers, big field. For example, people who would make desktop applications, like let's say Adobe Photoshop or Microsoft Word. And these are fairly popular apps that everybody had used. There will be people who have used only, let's say, Figma and have never used a desktop application like Photoshop or Illustrator. And similarly, let's say domains in finance, right, where Excel sheets are very important. There will be people who have worked only with Google Sheets and have never used something like Microsoft Excel, for example, right? So fair to say that, I mean, a lot of people moved from desktop to web, and similarly there are people who would have done things like, I know people who are Instagram creators, and they have shot their videos on their mobile phone, edited it in some app like InShot or Filmer, and they published it via the YouTube Studio app. So they are literally running a business, billions of dollars worth of business via their mobile phones only. And that's only increasing. The trend is increasing because there are more and more people who have been exposed to internet only via mobile and never via desktop or web, right? So the mobile field is also definitely growing. More and more people would be making mobile apps. More and more products would be launched directly on mobile. That's going to be happening. Okay. Next, another very different field I would like to talk about, and I came to it after these because this is a field that generally exists in a little more established companies, is SRE, Site Reliability Engineering, or DevOps. Now, Site Reliability Engineering was a domain first time started by Google only. So there is a website, sre.google, which talks about who is a site reliability engineer, right? So this domain is more about like when Google realized that we have so many web services that are running, we have so many products that are running, that the people who build the products, the people who work on the features, the people who are even building the APIs, apart from those people, we still need a separate entire engineering effort, which will make sure that the sites are always running, the sites are always available, the requests are always resolved, and when more users come to our website, the traffic and the load can be handled, the site does not go down. So making the site reliable itself becomes an engineering problem statement after a certain point. And this is a field which does not exist in early stage startups, because there the backend team would be responsible for keeping the servers up. But as the team grows, what happens is then you have to split the responsibility of keeping the server up, deploying the latest changes to the server, maintaining the security of the server, handling the load on the server as a separate entity from people who work on the product and the features. So that's a SRE becomes a completely different track and a role, and which is sort of interesting for people who want to be, DevOps or sysadmin. Sysadmin is somebody who is like running the systems, like installing Linux on the server, installing the required dependencies, creating Docker and Kubernetes containers and deploying it, automating the deployment so that whatever code the engineers are writing automatically gets deployed at a certain time of the day. All of these things people who want to do. It in itself is a very big field, okay? And there is the Cloud Native Foundation, CNCF, which is sort of growing in size. There are a lot of open source projects which are working on these problem statements, and a lot of tools in terms of how to observe which servers of yours are up, which are down, how much data is passing through them, is the load increasing. Let's say somebody like Hotstar, on the day of IPL the load increases infinite times. Right? So how will your server scale? More servers will need to be deployed, load has to be balanced across them, and then after IPL is over, it has to be downscaled as well. All of these things are the SRE DevOps domain, and that makes for a separate domain itself in software engineering. Okay. Then there is another field which is growing more in importance, is called the data engineering. Now, data engineering, why it exists is because how do we track our users, and to which users should we provide certain features which they will use, or to which users do we advertise so that they will buy our product, or we have advertised a user and they're interested partly in our product, we need to push them some more information so that they will buy, or which new feature we have launched has worked well with which audience. All of these things need observing a lot of data. And as companies grow and the number of users grow and the features grow, what happens is this entire domain of collecting data from users, putting them in databases which are appropriate for this scale of data, like a database where there are going to be 10,000 rows, and or maybe even 1 million rows, and every day 10,000 new rows are created, and people are reading maybe 1,000 requests per second. This is very different from, let's say, somebody creating an analytics server of, let's say, Google has this analytics server who's tracking which users are doing what search queries, and then from there going to YouTube and which video they are watching. This entire data, if they're processing, then the number of events that are happening there is in order of literally billions, sometimes trillions of events happening every second, right? So designing systems which can process this data and then also store it in such a way that we can actually derive analytics out of it so that we can do data driven decisions for business becomes a separate field. And there are people who are in data engineering, and I just want to mention that data engineering is not data science, right? it's not about like data science is about how do you interpret the data, but data engineering becomes an entire field where you have to create the systems which can deal with this data in the first place, which is in a way a specialization of backend engineering only. So people who are in data engineering are not people from data science background, but people from actual software engineering background. The only thing is the difference in the challenge here is that the volume of the data is so high that you have to create systems which have the level of performance and the level of reliability that no data is missed and all the data gets actually processed. And you have to deal with very interesting challenges, like for example, some analysis that I want to do needs to process data from two different databases, how to fetch them in real time and punch the data together and show some graph. Doing these problem statements are very difficult, so this has become sort of a fairly new field. The thing is that again, this is gonna be happening only at, let's say, products which deal with a lot of financial data, or products which just deal with so many users, like millions of users or billions of users, where the data is of so much volume that you need separate engineering to handle this kind of a thing. Now, especially in the fintech domain, like say somebody working at NSE, National Stock Exchange. Now, they would obviously have a big data engineering team working with data because that's an important part. But if you have an app which has been recently launched, let's say, take an example of, let's say, Zepto, which is doing orders in 10 minutes in India, right? Obviously, today, right now, when the app is immediately launched, you don't need a big data engineering team. You might not have data engineering openings in that company. The backend engineers would be dealing with data pipelines and all. There would be a day and a time when they're dealing with so many orders in a day, so many events happening in a day, that they will need a separate data engineering team. So larger companies definitely have data engineering teams, and they are pretty large in size, and you would need good maths background, a little bit of data science inclination, and a solid software engineering background to sort of get into these kind of roles. Finally, there is the field which I definitely want to touch upon a bit in terms of detail. I think we have a lot of great people at Scalar like Varma and Mudit who can talk about ML and AI, but machine learning engineering is obviously another domain. And while I don't want to get into more specific specialities inside that, but I just want to mention that, let's say, ML engineering is a legit separate domain from everything else, because there you're dealing with something very different. You're not dealing with information systems. You're not dealing with an app with an interface that users will interact, or you're dealing with data coming in through an API and you're storing in a database. It's very different. You are creating algorithms that can look at some data, look at their results, and learn how to create those same results. Machine learning is basically that. You create a system where you, let's say, I was recently seeing a machine learning example where somebody had created a game where there's a car going, and they have created this thing that if the car reaches the end, they get a reward for finishing, and if the car touches the walls, then the game gets over and the system gets punished. So there's a machine learning system which can learn. They can first do some random inputs, try to make the car go left, right, and they can keep doing it till the machine learns how to play the game. They can take the car from start to end, and they can play as good as somebody who is a good gamer. Now, designing algorithms which can learn how to give certain inputs to the car so that the car reaches the end, designing these algorithms, and then designing the systems how we can capture the data, whether the car is going correctly or not, and how we can feed the input like left, right buttons for the car. Designing these systems is what, let's say, a machine learning engineer works on. And there are many fields where machine learning is changing the game. For example, let's say in natural language processing, which is one of the specializations in terms of machine learning, two of the very biggest fields inside it is natural language processing and computer vision. So obviously when you put up a photo on Instagram or something, Instagram automatically knows whether it's a photo of a dog, whether it's a photo of a cat, whether it's a photo of a model, whether it's a photo of a landscape. So that people who watch a lot of landscape videos, they are shown more landscape videos. People who watch a lot of dog videos are shown more dog videos. People who see, say, Bollywood content and models dancing and all, they are shown more Bollywood song videos. How are they able to do that? Because let's say the video does not have a description which says that this is a Bollywood video or a dog video. The machine learning algorithm, the computer vision algorithms can detect what type of video it is and tag it accordingly and provide it to more users. So similarly, Netflix or Prime or Hotstar, they would have recommendations algorithms which recommend people similar movies to what they already see. Almost all fields are seeing some or the other way in which machine learning can be incorporated, and that will improve the experience. And wherever these fields are there, machine learning engineering has obviously a lot of demand, and you can get into data science, machine learning, AI to learn how to get into these fields. So that's, I think, a rough summary of some of the major roles that exist in software engineering. Like I said, I mean, backend and front end engineering, very old sort of streams, and gonna be there for the foreseeable future because most of the software is actually that. And to start off with, how everybody starts off with creating a backend or a front end app, and then they get started. Mobile engineering also, and then as you know, bigger companies are coming in, dealing with the data, so data engineering becomes a specialization. Machine learning is obviously an upcoming field, and like I said, site reliability also becomes sort of a domain. It comes down to you to figure out which is something that you would be most interested in. And especially people who ask where should I go, I generally suggest them that, hey, take 1 week and try to build a mobile app, and take a week and try to learn how to set up your own server on AWS, or take a week and try to build a basic machine learning algorithm that can detect the sentiment of tweets or something like that. And dip your toes into the water for each of these fields, figure out which is something that you like the most, and based on that, decide which direction you can take your career in. And many people switch from one field. They start with one and they switch over, and so it's like the doors are not closed, you can always switch over fields. But that's sort of the length and breadth of how the industry looks like. You have more such doubts about your career and which kind of fields you should go to, we keep making more such videos and content here at Scalar. Please like this video if you liked all the description that you had here. If you have more such queries, feel free to comment, feel free to write to us asking your questions. We would love to make more videos on your queries, and definitely subscribe to keep getting to know more about these things. Thank you so much for tuning in.